Thank you everybody for joining this call. This mid-year webinar that we call it. So, we do 2 webinars per year for the RobotStudio product. We usually end the year and mid-year because that's coincides with our, bigger releases and so forth. And in between we have what we call application webinars. We had one for a quarter ago about 3D printing. You can see it on our website. Very well visited, very good, very interesting. And we'll have a new one coming up after the summer period in September, October, somewhere. More things will be announced by that. But as I said, welcome on this one. And for you, I know there are a lot of people that usually attend these events, but for you who doesn't, a very short intro what RobotStudio is. RobotStudio is ABB simulation software. It's used for simulating, programming, configuring your automation solutions. And you can even do that before they are built. And that's the whole purpose, to do all the tests, to validate the things, to invest smarter, to reduce your risk. Everything about offline programming and simulation. So that's really one thing. And as you can see, it's not only about the robots, it's also about the entire automation systems, connecting the sensors, the IOs, the safety, hosing, clamping, fixturing, everything that comes in automation cell. That is what RobotStudio is all about. And that is what RobotStudio does the best. So that's one part when you actually are planning and doing new stuff. But it's also about tuning and optimizing ongoing productions down at the shop floor. The robot should continue to produce. It should not be stopped for doing optimization or introducing a new part or anything else in that cell. That should be done offline and it should be done in RobotStudio. And this is what RobotStudio really does best. And we have more than 50,000 users weekly that are depending and working with RobotStudio. And we are super proud of that. And talking about a little bit of the proudness, we have a few things. And as you can see, we have 50 years now as we first launched the first industrial robot. And I will give you a little bit of a sense, show them some movies. I know maybe the quality could be a little bit bad. It's a bit about the platform and events that we drive. But this is something that really would like to show our superior motion control and how that really fits into RobotStudio. Because what you really do here, you program a robot and you just don't just simulate it. You actually program it and run it how it should be in reality. And once you're done, you can simulate and verify this and push it down to the robot at the shop floor. And I think you all remember the Fanta challenge that we did for our motion control for several years ago. This is the same thing, but very much more advanced, reducing out 0.6 millimeters as a distance, and everything is programmed inside RobotStudio, just pushed down to the robot. And that things really ties the things together, how it works with the robots. And I think that is super cool. Superior motion control. We have the whole chain from start to the end to simulate, to test and verify anything. And it's all because of this thing here, of a virtual robot controller, which is like the true differentiator. This is the DNA, this is the soul, this is the brain that we have, and this is what we build all the products around. Because just as we saw in the beginning, when you simulate and test everything, it's not just a simulation, it's a true programming. So what you see here on the screen is what will happen and what we get down at the shop floor. Same motion, same configuration, same cycle time, even same errors, which you should love and have offline. So this is what I usually tell, and this is what is the difference by just having a simulation tool and by having a true virtual digital replica copy of your simulation or for your offline programming. So by that, we jump into the topic of today. And the first thing that I would like to start with is a little bit of an engineering phase, and then we head over to collaboration, talking a little bit about our product offering, and a Q&A, as Abid said. So starting first with something that we have been worked with quite a long time now, or something that we are super proud, but still in the early beginning. It's about the collision-free automatic path planning that we have in RobotStudio. So as you can see here to the left, you have like a traditional cycle programmed inside RobotStudio and tuned down at the shop floor, to speed up the process. with initial cycle time by 4.1 seconds. Instead, if we let RobotStudio's collision-free automatic path planning do the path for you, you can almost by seeing it, see how much smoother, how much faster the robot goes. And by just this short, one click selecting the targets, we were able to reduce the cycle time by 20%. And as a bonus, we take a more time optimal path. We can even reduce the energy consumption as well, in this case by 15% compared to the initial cycle that's programmed. And that is kind of cool. And this is something that we have, and this is something that has been there. We are still having the joint targets as an output of this one. This is something that we work with, and there's a lot of questions about this. And it will come as well, rope targets, the Cartesian targets as the output of this one. And I would also like to show you this one, because this is pretty much a traditional way how we program. You can see to the left here where the robot moves, we have this, 1 point for each tray, and then we offset rel tunes the things towards each, pick or drop position. This is like traditional programming. So this sequence will be more than 36 seconds, and then instead we let RobotStudio generate individual, unique, optimized path for every pick and drop. And that ended up that we can, reduce the cycle time by 11 seconds per tray. Quite amazing, And you can even see by just looking at the robot how much smoother the robot goes. This is something you have. I hope you have tried it out. If you haven't, do it. All right. Super cool, super easy. And I will do, as always, some demonstrations on this one. Right. And now we'll jump into some new stuff that we have been, achieving or adding to the collision-free path plan. The first thing is about that we now can create the collision geometries a little bit more customized. For us to calculate fast, we convert, the CAD data and everything into complex size. It's for us to speed up the math, to speed up the calculation. But sometimes you need to adjust it a little bit, and I will soon demonstrate it that we now have added some sort of customizable setup for how to tweak and tune this. And we can use this multiple objects, and we can really work on the details for this one. And as you can see, we also have a preview. So when you change, you can see how close it gets to the original geometry. Another thing that we've introduced as well is about this one, because it could be quite challenging sometimes to find, you create the path and then it sends collision. But where does it collide? Here we can highlight the collisions. We can debug the path creation, showing maybe that the geometries, the collision geometries was too bold and not that smooth as needed, really. And then you can need to shrink it, or that the targets wasn't reachable, and so on. This is one way, to debug and set up and do this. So these are two utility things. But then we added some really nice things into the automatic collision-free path planning as well. The first thing is to the left, where you can see that we now included this track support also, allowing the robot to plan with the 7th axis the track as well when we do the collision-free path plan. So this is first step. Next step will of course be that we can be using gantries, multiple axes as well into the path plan. So this is one thing. And the second thing that we've included is also that when we have this possibility, that we create a robot program, we select the positions, there might be a more optimized position for the robot to reach those targets. So we can even further decrease, the cycle time and energy consumption. And that is also part of the automatic collision-free path planning right now. So let me, demo that to you. So I will first swap into this one. And the first thing that I would like to show is a little bit on the collision geometries. So here we have this rack, and how we first interpret this one is like this: a convex hull that covers everything. But it can be kind of tricky, to move into this one to do certain things into the different slots in this rack. It will always, of course, collide. So we can set the different collision geometry detail level. So first, I mean, we can go to a little bit more medium and we can see better, but still. But if we even want it a bit more advanced, we can do this, customize it. So we can say specify the number of convex hulls, we can specify the resolution, how tight and so forth it will get. So let's say that we can say we want to have 32 convex hulls. We should have as few convex hulls as possible, and some sort of tight, the resolution is how tight the object is to us. We do preview, we calculate collision geometries for this one, and you can see turned out quite nicely. And we press OK, and we have way much more better collision object to work with. So we actually can use it to stick in things into that rack. So that was the first thing. The second thing that I would like to show is about this auto placement of the robots. So we have a cell here, a robot that we jump to these 3 different targets between this super advanced cell, as you can see. And as usual, we just select the targets. We say create the collision-free path, and we bring up this dialog about the sequence. We have a few options, the distance and so forth, but in this case, we just say, hey, please create it for me. And I press create, and it fails. And now we have this, the collision-free path output window that we can use. We can just double click on this one, and it visualizes really that this position is not possible to reach. There is a collision between the link and this target. So with this robot placement, we cannot reach that target. So instead, we can use this one, find optimal robot placement, a new thing that pops up now. And that is a little bit of a grid. You can see the size, the grid, the area. By default, we have 1 by 1 meter of a grid that's there. We can also say that you can have the possibility to vary in the set axis as well, to change the height of it. So let me do that as well and just add 500 millimeters as well. And we press search. So now we start calculating the optimized path, the optimized placement for that robot. And we look in a little bit to, what we optimize for is the shortest path, really. So of course we try and test quite much things here, obviously. So it takes a while because it's a little bit of the size of the grid and about the complexity in the geometry and so forth. But once this is done, you will see that we have a lot of different, suggestions. So we are done. You can see we have this, a little bit shown them. Here's the best result. You can see this ghost robot that is here. And this is the best placement of the robot. So now I can just say, use this one and move the robot to this one. But there are other possibilities as well. This is all the placement of robots that you can use. You can see all the green dots here. And here we have all the tests that we have performed in this grid of searches that we do. There is some sort of legend here. You can see the light green is the best one. The little bit dark green is good, but it has more than 10%, or more than 10% longer path to do that is generated. And then, of course, the red is invalid. But I would like to go with the best one. So I just say this one. I go with the best and change the speed a little bit, maybe like this. And I say create. So we place the robot there. And we just move it, and we have been creating and generating the targets. So I just jump to the start position like this, and we have that, and the robot can move. So as you see, with a few clicks, with some few calculations, and we have created both an optimized placement for a robot and a collision-free time-optimal path. Kind of cool. It doesn't take that long, to do it. So that was one thing, auto placement. The next thing that I would like to show is about, let's see where I have this, about the track, that we can now include the track as well. So here I have a station. There are 2 gluing stations each end, and the robot will move from the home position to this one in there, and to the other one there. and we are back. Okay. Same setup as always. Select these targets, so the sequence is a little bit go to this one and back home. So I just say create a collision-free path, and I will also include move back to the home like this. So you can see home, station 1. Then just speed up a little bit. Let's go like this, and I press create. So we start generating, calculating. This is like a production cell. You can see a lot of details in this different including different stations. So that one requires a little bit more of calculation time to find the collision-free path. But it still will take way much shorter than compared to doing this manually. And boom, we are done. So I just close this one. I can push it down to the robot controller like this, and I can just say go. Robot moves around, and you can see it moves a little bit differently compared to maybe how we have programmed it. Moves around into the second cell, goes to the dispensing tool, and back home. And I think this is one quite fancy thing, but what you also should think of is not really, we don't spend too much on like program robot, you should do this and that. We pretty much just tell the robot, this is how you should do it. And I think that is the beauty with collision-free path planning. And we also include the track and optimal placement of this. I would like to show you one more thing that it could also be worth mentioning. And it is also about the collision-free path planning, but here you can see we also can bring in scan data, meshes as well, sensor data that can be used. And here we have a program from the beginning. You can see it should just go up and down, and you can see it collides with objects in the station. But just to visualize, to show that we can also include and take care of scan data mesh. It could be like a mix of both solid K data, scan data, and we can do collision-free path planning on both, or all type of different type of objects types. So I just do that. I just will jump to the home position. I just do like this, speed up a little bit like this, and we create the path. We're done, and as you can see, we avoid by using the meshes as well to not collide. And this is of course kind of cool, because then you can start scanning. If you already have a factory, you can scan it, you can bring it into RobotStudio, and you can use that scan, to use the collision-free automatic path planning. If you haven't tried, path planning, collision-free path planning RobotStudio before, please, go ahead. It's fun. It's extremely powerful as well. Sweet. I will jump back to my presentation and continue a little bit. We have, of course, not only worked with the path planning parts. We have added tons of things in the latest versions of RobotStudio. We added the gizmo, we enhanced it for every release. We add a few more things. Super powerful, super appreciated. But there are some other things that we also would like to mention that we have added. Replace robot. This one is a really good thing when you're sitting down in an early phase, proposal phase, and you would like to create, your station. And you start with something, you build up quite complex things. You have a program, you have maybe even configured, you have, in this case, you have external access, safety zones, and so forth. And then you realize, shit, I should have changed, picked another robot, longer reach, higher payload, or, things like that. Before, that was kind of tricky to switch this. Now it's just a click away. You just select the robot, you say replace robot, and then you have this list, as you can see, with the different types, and you can just swap it. You keep the system, but you change the robot type of that system. And you maintain all the configurations into it. Super handy, super nice, especially when you are early in the proposal phase, when you test different strategies or different configurations. Here are two other things that has been added. And what these two things has been one of the top most frequently requested features. It's about supporting offsets and rel tools while you do synchronization and simulation, but it's also about supporting world zones to be able to visualize them. Otherwise, it's kind of hard, to where are those things? You do the rapid program and you have no clue, are they on the right place? Are they on the right, size? Does it really cover the things? You haven't been able to visualize them before. Now we can sync them up to RobotStudio and can show it. I will do a super quick demo of that one as well. So I will bring this one and I will start with the world zone. So let me jump into Rapid, and you can see we're here in the Rapid program. We have an offset. We also have a rel tool in this path. So I do as always. I take this program and just synchronize to the station. I take the path like this, and I bring it up. And we look into the path, you can see we have the offset here. And if I just do view robot to target, you can see we used offset, 100 millimeters in the target position. We have offset it. Same things goes for the rel tool. Here we have just pushed it down 100 millimeters. So with this one, we can synchronize, we can simulate, and we can work with them quite seamlessly for the rel tool and offset, because they are used so much in a robot program. All right. I'm moving on to the world zone, and in this case, I will switch back to Rapid. And you can see here, I have a little bit of a procedure with some world zone declarations. So I just switch back to Studio or into the graphics. I synchronize that to the station. I bring up the zones, and boom, here we go. Here we have the zones. And they are also part of the program. So you can they are as action instructions in this one. So you can do some edit. You can do edits of them. You can change like the positions, and you can change some sort of properties. So let me just do like this, increase it a bit, apply, close it. We can also change some of the visibility. Let's say with it, this guy is green. This one is yellow or blue. You can see. So this is how we work with. There are a few constraints, though. As you can see, if I switch back to the Rapid program, you have to define world zones in line. You can see we have the values. It cannot be used as a declaration up here. It has to be inline values. The same things goes for offs and rel tool. It has to be part of the instruction, those numerical values, so you know. And when I have the opportunity, why not show a little bit on the move and rotate? I think there are some kind of cool things that you can see. We have this gizmo. We have like this one tool button that you can do, and you can select like this and drag it. And then you can see that pops up. If I do this, you can see there's some sort of control, a shift, and control and shift. So I do this, you can say we get some increments when we do this, when we do the jogging. If I go for the shift, it's way much more precise. And it really depends. If I zoom in, the increments will change a little bit bigger than this. And if I go like this, so there are increment and some sort of precisions. So that is kind of cool. Same thing goes, of course, when you start working with an object here, how to rotate them, and then you can play around a little bit with a different reference coordinate system. And if I don't go selected points, there will be completely different or things how we rotate or manipulate the things, So if you haven't used this, extremely powerful and very intuitive. All right. Moving back to the presentation, back and forth. Here we have some other kind of nice utility functions that we added. That we can copy and paste transforms from an object that have transform. And you can see we can do this, copy opposite from relative word or parent, and we can apply that on any other object that has a transform. And you can either select if you just want the position or the position and orientation, etc. on this one. So you can copy and place those. The new thing that we've added, because this has been there for a few releases, the new thing that we added is actually that it can do this inside the input controls. There are 3 dots that have been that we can switch before quaternions and RPI angles or Euler angles. Right now, we can also see that you can copy and paste those as well. So you can paste them and copy it into, and you can also use copy here from one object and paste that into this one, just to make it a bit more handy, more convenient, when manipulating your objects in the scene. Just a reminder, this is not a cool thing that we added. Right now, you can also start directly communicate by submitting your feedback to us. It will end up to the dev team, to us. So you can just bring it up, and you can see there are a few things. First of all, you can see up in the right corner, there is this submit feedback on the desktop. When it comes to the cloud, there is under your user, and there is a submit feedback dialog that pops in. So here you write the topic and you read your description. And if you want, you can also say, hey, you can contact me about this one. Then you have to type in your mail address. If you have a cloud or you sign into cloud as well, if you're a premium user, you have a cloud subscription, you have to sign in, that will pop up automatically. We might contact you. We will not guarantee that we contact you. We might contact you if you have some feedback. It could be good, it could be bad, it could be, whatever you want to share with us. So you start using it both in cloud, both in desktop. But it's not for support. I have to remind you of this one. For support, we go the traditional way, your local APB contact. So we get it into the system and can work, so we don't lose track of everything. One thing more that I would like to mention is about this notification bell that pops up. Here is a notification about new things that happen. For example, about this webinar, it could be a notification here, but it can also be that your models or your robot web packets, etc., have been updated and added. I will show a little bit quick later. Start using this one, kind of cool, direct link into the R&D dev team. Another thing as well, you can see here we have this little blue dot as a notification that there are updates to the things that you use inside the station, packages or models. But we had some challenges also well, because now we have also moved everything into the cloud. All the models we moved into the cloud, so you download the things that you need. The problem has, of course, been now if you go offline, you go offsite into factory, you can prepare now by selecting all models or a few of them, download it and transfer it to your colleague that sits in the office or in the offline world. Non-connected world, or bring it with your PC. So just to remind you about this one. So a lot of things are happening, and they move more and more things into the cloud to be distributed in that way to shrink the distribution size of the product, and to be able to update it quite continuously, not only with the releases. Back to a bit more feature side. We have had this stop positioning thing for a while. That we can have the stop positioning, so you can actually see where the robot will come to stop. Now we've also included track support for this one as well. And that means that you can also get the swept volume, the volume of the moved robot plus the track as well. So let me do a quick demo of that one. I will just jump back to the program that I created before, and we have this robot. So the things that you just need to do now, you remember, you always go to the signal analyzer where you would like to see things like that. But in this case, we have a special one which is called Quick Add Position Signals. Select that one. We get some disclaimer that we understand the stuff, what's happening. And you can see we start subscribing on certain things in this one. Okay. Also on the track. And I will just maybe speed up a little bit. So I will just select all the positions here that we created, modify instruction speed. I will just go a little bit faster so something happens. Okay. Synchronize rapid, press play. The simulation is on, and we just start, doing the recording. The robot moves quite quickly, swings around, and now we'll record for every tick using the virtual controller where the robot will come to a stop. Here is, of course, the beauty of having our virtual robot controller. Switch into the playback button, you can see, and this was the latest recording that we did. I think and we can see when we drag here, you can see the robot is moving around like this. But I can also, turn on and off the stopping distance. So if I zoom in a little bit, you can see the ghost robot. I know it's a bit jumpy now when we do things like that, but you can see this little shadow and the differences between. And I can measure, I can click on the robot, can we see the distance? It's not that far. In this case, it's like 30 centimeters. So it's not that far. We don't go that very fast. If you want to use that then later on for your design of the safety zones or for your fences, you can use the swept volume. You can say generate the construction, generate the swept volume based on the movement plus the stop position. And that takes a little bit of while. So I prepared a little bit, and I just made swept volume. As you can see, I'll just make it visible. You can see here is the space of what is needed for the robot to move or to be used in this one. And based on this one, you can set it to your CAD engineers to set up the fences, or your safety guys that work to the safety zone, to need to set it up and protect your environment. Or protect your environment, protect your workspace. By this, the benefit of this, by rather reading, your brochures and data sheets, how much stopping distance you need, it's way much better, because this will tell you exactly, thanks to the virtual robot controller, how much space you need, and we can reduce the floor space and the footprint of that side. So now we include tracks as well. Kind of cool, kind of handy in this setup. Nice. I just move on. I have so much things that I want to share. So I will go quite quick. But I hope you get some thoughts, you get some ideas, and that you can play around a bit later on. And you can also see the recording afterwards, of course, if things are moving too fast. This is something I've had for a long time, about the robot stress estimation. And that means really, it's no problem really that the robot can come to stress, but you can do programming of a robot that causes the robot to be a little bit more stressed than maybe optimal. Rather, and that could lead to that you have to service to maintain it a bit more frequently. And if you reduce it, you can even prolong, the life length of a robot. But this is, of course, extremely hard to understand. Where does this happen? How do I get these insights where to change and update the program? Or where is it really, happening? Usually, we see a lot of problems, where line builders, system integrators, our programmers, they go always fastest and with stop position. That usually causes a lot of stress. But usually that is not really needed. But it's a little bit stressful for the robot. Even if the robot handles it, but it's good to have those insights. But it could potentially lead to lower total cost of ownership. So that's a stress estimation. We have also added a new thing, also for the Omnicore. The previous one was only for Omnicore, and the bigger robots is 5767 and 7700, 600 robots. But now for the Omnicore, we have also introduced another signal that shows how much power you're actually using from the controller. And that is really good, because that gives you, an indication, are we too close to maximum? Can I include some external equipment, maybe sensor data that really starts eating the CPU of the robot controller? Or do I have enough bandwidth? The worst case, I even maybe have to upgrade to a bigger cabinet. We have these 4 or 5 different variants of the Omnicore controller. Maybe you have to step up one of those. This signal can guide you and tell you as well what are the bottlenecks and where does it happen. So this is called a power supply utilization signal. I will show you that one as well. Let's see if I just find the right one. So here we have this one. So I have a path, I have a robot program. And we bring out our best buddy here. It's always the signal analyzer when we want to understand things that happen inside the system. So I bring up the signal setups, and you can see there are a bunch of signals that you actually can subscribe to. So in this case, I start subscribing a little bit on the joints. I also, you see here, I have the stop estimation signals that I showed before. I would also like to see the stress signal, because you will see a big correlation between the stress and the power supply utilization. So I just select that one. Stress, I select the target change, because then I know exactly where in the program things are happening. And then we have this new little guy down here, the power supply utilization. I check this one as well. And now I'm happy. I close it down. I just want also maybe to visualize the things that are happening. By the way, before doing it, here you can see the submit feedback. Easy like this. Yes, you can contact me, you type it in, and you say, nice, this is good. So you just do this, and you can send those things to us. And we can, just a reminder. Moving back to what I was supposed to present. So I just want to show you as well on trace. So here we have this TCP trace where you actually can monitor the things that are happening in the path. You can subscribe to a certain signal, and using color scaling to see how close we are to the different limits. In this case, I would like to enable the trace. I would like to select all the different signals, and here you can select IOs, you can select event logs, you select, whatever, all the signals that we can expose from the robot controller. But in this case, I would like to show where the power supply utilization is. Okay. And we select the color scales from 0 to 100 in percentage, close it, and we start playing. The robot starts moving, and you can see we have this trace, pretty much green on this green side, safe side. Things are progressing as we would like it to do. And I swing around a little bit extra just, to get some sort of, feeling that happen. I can now go to signal analyzer, and we can now observe a little bit. So I will just close a few of those things here. I just show the maximum just to have it, and you can see it quite correlates here. So we have the events from the different programs. I will actually do like this as well. I will go to the playback here, bring it up, and you can see we have this timeline. So you can actually really see in this case, here we have the stress, here we have the power supply, and you can see we are far, from using the whole range. There are a few things, and you can see there are, as soon as you start, consuming a lot of power, it also a lot of times, correlates with stressing the robot a bit more. And if you want to change something, we can jump here, we can go to the program and really look into, okay, we have full speed, we have fine position in this case that we can change it. This gives you some insights. This shows you possible bottlenecks. It also shows you, if you can add more equipment into the robot controller without, disturbing or slowing down any performance. Nice, good. And that pretty much, concludes a little bit on the first session that I would like to, that I shared about the things inside the RobotStudio desktop, the things about the engineering, how we can program it faster, but also get some more insights into robot program, how we can help you to be even more and better robot programmers. The next thing is about, of course, about RobotStudio Cloud, about the collaboration part. And we are building this ecosystem, as you know. We have had a desktop for a long time. We introduced cloud 1.5 years ago, but it was way much more than just an app. RobotStudio Cloud is, a way to collaborate and work together and taking virtual robotics into the cloud by using cloud storage that you can share the products that you have side in the desktop product and store them into the cloud, just as we use OneDrive for our documents, etc. Here we use RobotStudio Cloud to invite others, to collaborate with others, and to work in a collaborative way. So you don't have to use anything about the cloud. It's more that you work and use RobotStudio Cloud as your file storage and as your version control. Because as soon as we start, collaborating, mismatch with versions, etc. and so forth. But we have taken, software disciplines, we have taken Git and moved that into the cloud So we can dip, we can merge, we can do all these type of things in a very easy, straightforward fashion. Then we have the Cloud app, and I will show a little bit about this one. It's more about tuning, tweaking the Rapid program, not changing in the layout, but if you want to do some minor modification, very streamlined, intuitive interface. And we have the virtual controller running in the cloud as well. So when you do tests in a web application, just using your phone or tablet or whatever, you can be sure that what you see there is also what you get, because that's cloud, virtual controller running in cloud. We also include AI Viewer. I will come back to that a bit more a little bit later on. So I just continue because, talking about collaboration, this is what we do now, and we've added a lot of nice features and things into this one. And right now, cloud is using very much for version control to create products. And the latest additions that what we have is to manage a product. So if I invite others into it, I can now also take care of branches. I can take ownership. I can claim other branches, and I can do commit. I can do merges and delete. So we as a team can work together. If someone quits the company, I can claim his branch and work with that one. Because branches is the thing. I have my main branch. My colleagues have their branches as well, and we can merge and do things together. And this ownership, if I do have the ownership first, I can transfer this to someone else because I'm going on vacation for a while or I'm quitting the company. So that is also something we've added. And then also about invitation to control that, depending to revoke those invitations, to prolong it, and to copy and send those invitations. So these are a few things that we added in the collaboration. About the version control, we have added a lot of different things. And version control is, of course, to be able to keep track what happens to your automation system. And it's not only about, the rapid code, the robot controller, it's about the entire layout. So we work in individual branches, and once we're happy, we can merge them to others. And we can commit and merge and do so. And one of the most important thing is, of course, that we can restore. If we have screwed up, we want to go back to a version that we know worked, we can make a restore out of that. We have also added a few other things. We can do a comparison, not between, and that could be between any version in that branch, so you can see what are the changes that happen. And when you do some changes in the cloud environment, we can also make a review before doing action. And we can also discard some changes that we don't want to put into the version control system. So this is things that happen in version control. So we see we push a lot of things because this version control can be used on the desktop cloud product as well. We just have it there and it just works. Share recordings, super neat, super handy. We have the station viewers before. Now we have these share recordings that we just upload to the cloud. You can send the links and email this guy. They don't have to have any RobotStudio installed, anything. They just need a web browser. They get the link, they surf in, and you can share the proposals, share the layouts to these guys very easily. And that's also part of the cloud. We have also, I'm sure I'm talking about version control and handling. We increased the storage. Now we have 15 gigabytes per person in the cloud to store your products, facilitating, enabling collaboration together with you. And, we have tons of tutorials as well. If you think this went too fast, how should I do this? It's super easy. We have a lot of tutorials there that you can just go through and learn about how to use cloud version control, etc. But I will do a super quick demo before we switch to the Q&A. So I have a station here, and you can see when we open, you can see we have the possibility to open cloud products. These are my products, cloud products that I have. And in this case, there are two different branches. You can select which branch I should open. In this case, I'll open the main one. And you can see that as well here, RobotStudio in the main branch. So I can switch to show my cloud products. And as you can see, also, I just need to sign in. And here are my personal storage, my products that I own and that I can share with someone else. It's only mine. No one else will see them, will use them unless I share it to them. And here you can see the storage. I just use a fraction of this one. Here we also have the submit feedback, and you can see that I'm now logged in. If you want to have more information, you have the tutorials, documentation, and so forth to get in-app direct knowledge about this one. But in this case, I mean, I look into this one. You can see there were two different branches, and we have the main, and I have my branches here, and here are the things that I work isolated. If I want something to happen, I can do this merge. I can take the things that I've done and merge that into the main branch so the others also gets aware of this. We sync this. So I just merge this one, and you can see we get the diff here to see what are the changes that actually have been done. Okay, I've changed that one, I changed the speed, I've updated, and I just do a merge. So this is a new thing, and you see now I took everything there and just push it into the main branch. So now we have the main branch that I merged my things to it. I can open it up, and now I run the latest things that has been used from my side into the main branch. So here we start up the cell, and as you can see, we're waiting for the virtual robot controller to be there. And here you can do pretty much everything. You can see you can edit the code, you can change the things, you can step through it, you can change, you can do all minor things to your robot program. And you can be confident, that the things that you see here, it will be exactly because we have the virtual robot controller that runs here in the background that guarantees the same thing. So just, let me do, I can just change something here. I can change, let's say, change the speed very slowly. And you can see when I've done that, of course, I can run it. We can simulate a bit on this one, do a bit bigger, and you can see we can try it. I can also follow the program pointer, which instruction, I can put breakpoints and so forth into it, just to do some super, minor, easy debugging to look into this. If I'm happy with this one, I can push it into the version control. I can make a little bit of a review. I just let it finalize. I can make a review. I can see, okay, what did I actually change? Yes, I changed this one. I make a changed stuff here. And I make a commit. So I push that in to the version control system. And you can see here are my changes, and I can compare and view this. So now we are at the latest version. And the thing is, if I move back, let's see if I move back to the desktop, where did I have it? You can see someone else have done changes to one. You can bring it up. I will soon end. The only thing that I would like to show and share is if you want to export a viewer, it's super easy. You just do like this, and you can either export it to the cloud or locate it to this PC. And you can also create a link. So just do like this, do create. We run the simulation, we record it, and once it's done, it was pushed up into the cloud to this product. And I've already prepared because it takes a bit of a while, so I can just jump in. You can see here that I have a few attachments that have this one, and this one is then shared. I can share from this one here to share the files. I can download it, but I can also open it here as a station viewer running into the cloud without any need of RobotStudio. So it's kind of seamless, perfect for sales proposals, perfect sales pitches in early phase. And we can just, go ahead, play it around and use it like this. Cool. Last few slides. And it is pretty much about a little bit on our offering. So the things that I've shown you pretty much now is about the RobotStudio Premium or the Premium package. The things, the power functionality. We also have a free version that is there, mainly used for getting a robot started to configure it and do it, but it's not quite unlimited. That you have forever. Then on top of this, you can have purchase a RobotStudio Premium license that contains all these nice things that I've shown. Cloud capabilities, AR capabilities, physics, smart control, whatever. And then on top of it, we have power packs and CAD converters. And we will come back to these power packs in a session in the webinar a little bit later on. 3D printing was one of those, power pack, but we will come back with a new one a little bit later on. And I have a rough sketch here, a little bit what the different licenses contain and the different length duration of them. We also have a trial license. If you haven't tried RobotStudio, just download it and you can use it for free for 30 days. The same goes for cloud. You can also use for free for a while. And then you purchase it, you subscribe to license, usually a year. And when that year subscription ends, you can renew it and you will continue to have your premium functionality. If you don't use it, prolong it, it will fall back to the basic or the freemium version. So talk to your local sales guys. If you're interested to start using, to play around with it, they can help you. They can give you good offer, using RobotStudio, because this product can really help you to be more effective, more powerful, in your daily business. And by that, I think I will hand over to you, Arvid, for the last 10 minutes. I know it's a little bit short on time maybe, but I hope we have got.
Yes, we do. We do have a lot of questions that came in from our participants. So thank you all very much for that. So if you have a question for Magnus, please go ahead and put it into the Ask the Speaker and we'll get you a question as well. But let's start things off here. How does ABB incorporate artificial intelligence and machine learning into robot systems to enhance performance and adaptability?
Yeah, I think that's a super big question, but we do. And I can only answer it on the software side, but we do a lot of things in the robot, when you talk about item picking, vision, image capturing. We have something you call this AGVs, the VSLAM and things, how to navigate, we use it in a very broad spaces, but I can say we are very much just in the early phase. We in RobotStudio, we of course as well look into how we can use this one. We have a few things that will come. I will not mention anything really right now, but hopefully next webinar I can showcase some of the things that we have been thinking of and looking into. It's a bit vague, but I can tell you, of course, as anyone else, we are working quite heavily in this direction, so
Yep, I agree. AI is a really hot topic and there's a lot of things going on here. So hopefully we can share that in a later webinar as well. So thank you, Magnus. Next one is pretty interesting. How would you suggest to a complete beginner to start learning RobotStudio? It can be quite overwhelming for a beginner.
Yeah.
Is there a prerequisite that they should know before they start?
I think you're touching on something quite interesting, because it is a challenge. This is a bit of a threshold. What I would like to say is that, first of all, you should be interested, in robotics. You should be interested in maybe using a computer and sit down with it. The next thing is that what you should do is just download it, and we have a bunch of tutorials to get started. I think we have 60 tutorials that can guide you through the different steps to start getting used to it. And you have the full functionality for 30 days, so you can really play around for these 30 days. So I think time and interest and use the tutorials, I think you're ready to go. But of course, we understand it's a challenge. It's not that easy. But, start playing around with it. And then if you need more information, more help, we always have a local training facility within ABB in your local country that can help you. They have 5 days course. And there are also schools that educate inside RobotStudio with RobotStudio. So there are a lot of different possibilities. But start playing around first. And I think that's the best thing, and use the tutorials.
Mm-hmm. Yes, thank you, Magnus. So moving on to a more technical question. Is it possible from the simulation environment to detect the mass and inertia data of a tool if all materials have been set correctly?
It is actually, we have a CAD kernel that definitely can tell us. We have not that part of the product, but this is something on the wish list as well. If you have a right, let's just say, the CAD data, the CAD models that are accurate and you have the right material, we can tell you that. So this is a good point. It's part of the wish list, but we haven't done it yet. So a good point. It can be done.
Yep. Yep. It can be done, so let's do it. Yep.
Exactly. Let's do it.
Yeah. Easy peasy. So next question here. How does ABB leverage the Internet of Things and cloud computing to enable remote monitoring, control and optimization of its robot fleets across multiple locations?
I think this is super interesting, and this is of course one of the reasons why we have pushed quite heavily and moving into the cloud, to have those capabilities that we have. First, the virtual robot controller that can be running in the cloud, and then we have a few other tools that is happening in what we call Optifact, is like factory monitoring that we can connect the robot, and of course the vision is of course combining those things, that we actually can take the fleet, do calculations, do math, and use of course what we discussed before, AI, things like that on top of it to start optimizing the thing. So of course we're not just building a cloud for fun. We think it's an enabler for the future really to do this, because you really have to have the true motion control, the true behavior to have good optimization, and we are paving the ground for those steps. So I think it's a super interesting task, and of course we are heading into that direction, but still take a little bit of while until we get there.
Yep. Great, thank you. Do you intend to expand the machining power pack add-on to include the ability to work with more than one external axis?
That's a good point. Nothing that I'm aware of today. It's a little bit of a mixed setup as well inside Robot really now. I mean, we have a product manager just working machining and so forth, but I will carry this message to him as well, as I think it makes a lot of sense. So I don't know. I can't really tell, but I will ask him.
Mm-hmm. Great. Thank you, Magnus. Have you considered combining functionality, positioning, and selecting a robot for the task?
Let's see if I understand that topic. If we can, I mean, selecting and positioning the robot. You mean a little bit on the jogging side? How we actually manipulate the positioning of the robot. Yeah, if that's the case, I can say yes, that is definitely. I think that is one of our weak spots, honestly, how to position, how to move the robot. And this is one of the top things that we actually are looking into right now. How can we maybe extend or expand a little bit of the jogging or positioning capabilities of the robot? So there will happen a lot of really cool, interesting thing, and that we are actually working on right now to extend that one, how to manipulate, how to move, and how to work with the robot movement. It has been done pretty much the same thing for the last, 2 decades, jogging the robot like this. Of course, we would like to change the way you manipulate the object. I know it's a vague answer, but I can guarantee a lot of things are happening if I understood the question correctly. so it's a lot of ifs and buts and everything, but I hope I give you a political answer.
Yeah, that's fine, Magnus. So perhaps the other one, next question here could be more a precise answer. How do I find the add-in CAD converters?
The add-in CAD converters are downloaded from our, it's not downloaded, it's part of the licensing, really. So if you purchase a premium license, you will only have one format, and this is the ACES. That's our CAD kernel. So if you purchase another one, an additional license, you will see more formats that we support. So it's driven. You don't have to download anything. It's part that you extend or add additional options to your license. Mm-hmm. So that is the simple answer.
Yep. Great. Thank you. Then there's a question here. Is there a tutorial or instruction on how to best set up my production in RobotStudio? As we have many different projects and different users with different end effectors, a best solution would be desirable. And there's a comment here, we use an IRB 7600.
Mm-hmm. It's really hard to say in a generic answer on this one. I think some of the things that we have shown a little bit today, to find, usually what you do, you have some sort of temple set up in a robot program, how you would like to communicate with your PLCs, how that logic, how that structure is, and also maybe the sequence, how the recipe handling and so forth is happening. It really depends if you have those things structured. I mean, those usually gives you the skeleton of your robot program, how you communicate and get these orders. So that's one part, the logical way. Then when it comes to the more practical way of how to position or the layout or the geometry of the cell, I think you've seen quite cool things where what you can use, both in terms of to place the robot together with the end effector, where to find an optimized position for it. So I would say it's not an easy answer. I think we have to look into a little bit more your structure, your configuration to give it firm one, but some of the things could maybe help you to do this type of things, the things that we have added and included, and also to guide you in the right direction. But it's a lot more than just that.
Yeah, thank you. And then I believe there was a follow-up to the question about combining functionality, and this is the automatic position, which is a new functionality. And if necessary, if RobotStudio could help with an automatic replacement of the robot with another one that perhaps worked better with a path or something like that.
Yeah, exactly. So we could guide you, say that this robot would be more ideal rather than the one you have. I think that is a fantastic request, and this is something that we thought of, to have more guidance, saying if you will pick this robot, you will gain this and that. That is some sort of vision, a dream, honestly, that we're working into. So I love it. Perfect.
Yeah. That would probably also could include AI in the topics that we were discussing.
We can bring in everything.
So let's move on. We have 2 questions left right now, so we're a little bit over time, but we'll stay on and try to finish this Q&A off. Can the complete station be visualized in RobotStudio in real time if we relate to the physical robot? We can only see the robot without its complements, auxiliary machines, grippers, fencing in the simulation. Can we see the rest of the complete installation as well?
So let's see. So I understand the question. Of course, we are, driven by the robot in some way. That's what we do. But we can also, of course, link to any other device. We have a few connectors, drivers that can connect to pretty much anything. We have some sort of what we call smart components that could link to, for example, devices that support OPC UA or OPC, or we have native Siemens drivers as well, using Siemens. By that, you can get or extract the data from the real physical device down there and to be mimicked and displayed inside the simulation. And we can either collect a virtual PLC or virtual object or a real one. So I think we have the ingredients, the objects, that can facilitate and help by doing as well. So without knowing too much, I think there are things. So have a look at like virtual commissioning. If you Google that a little bit and search in tutorials and things like that, virtual commissioning RobotStudio, hopefully that can give you or guide you in some sort of right direction.
Yes, great, thank you. So let's move to our last question here. What innovative technologies has ABB developed for predictive maintenance and condition monitoring of its robotic systems to allow for proactive maintenance and minimizing downtime?
Mm-hmm. We have a tool which is called Connected Service, which is more of like an aftermarket service tool, where you actually can connect your robots via Connected Service to have this, what we talk about a little bit, fleet management. But there we can use and look into how your robot is performing, the actual values, the due dates, your service intervals, etc., and we can do a predicted of the maintenance that is needed. So it's already a product there. Look into Connected Service, which will help you and guide you through this, and talk to your local big guys. They know exactly what it is, and I think Connected Service is the answer for that one.
Yeah, I believe you're right. I've done webinars before on Connected Service.
you know the most of it because you're called into all of this.
Well, finally, I know something. I'm so happy. Yeah, and All right, let's just double check. I think we've crossed off all of the questions that we had. So it's so I don't know if we have users trying to communicate with us, but since we're over time here already, I will just hand it back to you, Magnus, for some final questions, perhaps some key takeaways.
So first of all, thank you very much for spending this afternoon or this day. It depends a little bit where you are, but this hour together with us. I know there were a lot of things that I would like to share, but I hope that I have triggered some of the thoughts. And maybe that you've seen some possibilities, some things that maybe haven't seen before, new ways maybe to use RobotStudio, but also how powerful it is and that you can rely on this in your daily business. Please, join us, contact us, talk to your local guys. We are here really to serve you, and we will be back in a quarter with an application webinar, and I will be back in half a year with the new, latest, greatest things that happens inside our RobotStudio. If we don't speak before the summer period, for you guys who will have vacation, I wish you a fantastic vacation and take care. And for everybody else, have a fantastic day and rest of the week. And thanks you for joining.